Okay, so you just finished an activity that asked you to try to figure out if something was a function or not. And so we're going to take some brief notes on that just so that we're all know exactly what a function is. It's a really important part of this class. So on your paper, at the very top, can you go ahead and write LT 1.2 notes? That's what you're going to write down right here. And then underneath it, let's just do a very brief description of a nice way to think of a function. If you've never heard that word before, exactly what does it mean for a relationship to be a function? A little bit later in this class, you're going to hear some relationships that aren't necessarily functions, but for the majority of it, we're going to focus on functions. So you've got your heading on the top of your paper, and then if you could just write this down, that a function, and the way we're going to think of it is it can't be at two different places. It can't be in a different place at the exact same time. Okay, that just doesn't make sense that you can be in two places at one time, and it's the same thing with a function. A function kind of has to, I remember it by thinking that it has to follow like the rules of physics. You know, that you can't be in two different places at the exact same time. And we're going to show this through graphs and through tables, but that is the definition that we're going to try to remember for a function. If you look in a math book or something, there's other definitions also, but I think this one is easier for me to understand, and hopefully it will be for you also, that if something's in two places at the same time, then it's not a function. It just doesn't make sense. Okay? All right, like I said in the last one that you did, if you ever need to pause this at all, just hit pause and play. If you don't understand something and you want to rewind it, rewind it. And if you need help throughout this, remember at the station that you're at, the interactive tutorial, the CHAMPS poster above you says that you can talk to your teacher. Okay, so if you need help, raise your hand if your teacher's not talking to anybody, or flip the cup over that's right by you, and we'll be over to help you as quickly as we possibly can. Okay? All right. Can you copy this table down? Our x's are our input, and our y's are our output. What we're going to do is we're going to take this table and we're going to plot it on this coordinate plane. Now this coordinate plane is only a first quadrant coordinate plane. It's only showing the positive numbers. So I'll put some numbers in here and I'll label this a little bit for us. This is our x-axis. This is our y-axis. And so when I look at our x's go from 0 all the way to 4. So down here I need to go from 0 to 4. Right here I see 2 3's, but you only have to write the number once. Don't write 0, 1, 2, 3, 3, 4, just 0, 1, 2, 3, 4. So I'll write that right down here. I'll try to do this evenly. 0 is always in the corner here. So 0 is going to be right here, and then 1, 2, 3, and 4. And if you could do the same thing, that'd be perfect. All right, now when I look at my y's are right here. They go from 2 to 10, so I at least need to go to 10. You've got a choice here. You could count by 2's and go to 10, or you could count by 1's. I'm going to show you something here. I'm going to put a mark for every one, but I'm going to only label every other one. So I'm going to go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't have to put a label next to every single one. You're smart enough to figure out that that's a 9, that's a 7, and so forth. Okay? Now what I'm going to do is I'm going to take these numbers over here, they're coordinate pairs, and I'm going to plot them on our first quadrant coordinate plane. So when I do that, 0, 2. 0, 2 will be my first one. 0, 2. 0 on the x, up to 2, put a dot right there. That's 0, 2. 1, 4. I'm doing this one next. 1, 4. 1 up to 4 and put a dot there. 2, 6. 2 up to 6. Put a dot there. 3, 8. 3 up to 8. Put a dot right there. 3, 9. 3 up to 9. Put a dot right there. And 4, 10. 4, 10. Now, I usually think of the x as time. It's not always time, but let's just say, let's pretend like it's time. And let's pretend like this is distance. Okay? So I want to show you what this looks like in a table. See, at this table, it says that at 0 seconds or 0 time, we are at a distance of 2. Then we'll call these seconds. At 1 second, we're at a distance of 4. At 2 seconds, we're at a distance of 6. But look right here. At 3 seconds, it says we're at a distance of 8. And then at 3 seconds, it says we're at a distance of 9. It looks like at the same time, we are at 2 different places. So because it's the same time and we're at 2 different places, this can't be a function. This is not a function. And the way it looks like in a table is when you have the same input and you have different outputs. Same time, 2 different places. Okay? The way it looks like on a graph is, see this part right here, how they're like lined up? They're right on kind of in a vertical line. That's the same time you're at 2 different places. So this graph also shows that it's not a function. So that's our first example. Here's one other example here. So if you're given a graph like this, one way you can find out, you can do, if it's a function, is you can do something called a vertical line test. Now you did this a little bit in your activity 1, but let me show you how this would work. You would draw a vertical line on the very, very left here. Let me make that a different color. Let me make that, let's say blue or something, okay? Okay, and now with a vertical line is going up and down. I always remember that by, if you know of somebody's vertical leap, like Michael Jordan's vertical leap was 44 inches, or LeBron James' vertical leap is 38 inches. It's how high they can jump off the ground. It's up and down. So I've got a vertical line there, and this is called the vertical line test. If I drag the line across like this, if at any point it touches the graph in 2 places, like right here, see how it's only touching right there, the red line? If it ever touches the line twice at the same time, then it's not a function. So we're good here, good here, good here, good here, good here. Right here, there's a problem, right? Because see how it touches down here? Let me highlight that for you. It touches down here. It touches here. It touches here. See how it's touching in a bunch of places. So it's failing the vertical line test. This would like be, if this is time, this is like being in a bunch of places at the same time. And as we drag this across, you can see it fails here, it fails here, it fails here, it fails here, fails, 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 fails. You know, finally it's okay again over here, but over here it failed all the time over here. If a pitcher fails in any part of it, then it's not a function. So this is not a function. Okay? So that's our other example. That's called the vertical line test. Vertical line test. Okay, and you kind of messed around that a little bit with your activity 1 for learning target 1.2. Okay, the very last example I want to do here is one like this. So again, we've got our table. Remember, this is x, this is y. We're going from 0 to 4, so remember 0 starts here, 1, even though we see 1 twice, we're not going to write it twice. 2, 3, 4. And then it looks like my y's go up to 7, so I'm going to do that same thing I did before. 1, 2, 3, 4, 5, 6, 7. You can go past it. You don't have to stop right at it. And I'm going to put an 8 there. All right, now let me plot these points. 0, 2. 0, 2 is going to go right over here, 0, 2, and be right there. 1, 3. 1, 3 is right there. The next one, 1, 3. I've already got the dot there. I don't have to put another one. 1, 3, because it would just go right on top. Same time, same place. 2, 4. 2, 4. 3, 6. 3, 6. 4, 7. 4, 7. And let's talk about this table first, then we'll talk about the graph. First of all, the table. Remember, it's not a function if you're in 2 different places at the same time. This is the only one that's going to be a concern, right? Because those are the same time. But you're not in different places. You're in the exact same place. So at 1 second, if you're thinking of this as seconds, and you're thinking of this as distance, at 1 second, you're 3 away, and at 1 second, you're 3 away. So you're not at different places at the same time, so that's okay. If you look over here, see how we don't have any dots right on top of each other in a vertical line? If we did the vertical line test on this, I believe, if I draw a vertical line right here and kind of drag it across, let's see if I can make that vertical, and drag it across, I believe you're not going to have any issues where you're touching more than 1 dot at the exact same time. So then this one, I hope it's obvious to you that this is a function. Okay? That's what you've got to know for learning target 1.2, is you've got to be able to tell if a table is a function and if a graph is a function. Okay, so now you're going to move to activity 2. In activity 2, you'll be able to work a little bit more on this before you take the practice quiz, and